Hi everyone. Today we're going to be looking at what we call the sine law. So, in your notebook, please put down today's subtitle, which is the sine law. And in brackets, please add in for any triangle. As you can tell from the subtitle, the sine law allows us to use the sine ratio in order to help us figure out any missing sides or missing angles in any triangle, whether it be a right triangle or a non-right triangle. Now, how does the sine law work? The sine law is based on the following principle. The sine law states that for any given triangle, whether it be a right triangle or a non-right triangle, the ratio of any side versus the sine of its opposing angle should be equal to the ratio of any other side versus the sine of its opposing angle. Now, this might seem like a lot to remember, but once you get the hang of it, you'll see that the sine law proceeds very quickly. So, let's jump in with a very quick example. Please put EX. I would like you to first take a moment to get down the following triangle. Go ahead, pause the video now, and draw it accurately. Alright, let's take a look at how the sine law works. Let's break down the theory of the sine law piece by piece. First, the sine law states that the ratio of any side versus the sine of its opposing angle. Let's form that ratio. So what I'm going to do is I'm going to take the 10 centimeters right here, and I'm going to form the ratio with the sine of its opposing angle. And its opposing angle is the 55. So I'm going to write the ratio like this. 10 over sine of 55. This is the ratio of the 10 centimeter side versus the sine of its opposing angle. Now let's deal with the second sentence in the statement, which is this ratio should be equal, so I'm going to put the equal sign, to another ratio formed by taking any other side versus the sine of its own opposing angle. So here's the ratio that we're going to form. We're going to take the missing side, our question mark, and we're going to form the ratio of that side versus the sine of its opposing angle. Let's get that down. So we have question mark over the sine of its opposing angle. And this is how the sine law works. Let's review the statement one more time. The sine law states that any side of a triangle versus the sine of its opposing angle should be equal to any other side of the triangle versus the sine of its opposing angle. Once you have this relationship set up properly, all you have to do is cross multiply in order to find any missing value. So in this particular scenario, cross multiplying gives us the question mark will be equal to sine of 40 times 10 divided by sine of 55. And therefore, that gives us a question mark value of around 7.85 centimeters. Using the sine law is not difficult at all. In fact, it's quite a clean procedure. It proceeds very quickly as long as you know which pieces go where. Now let's take a look at another example of using a sine law to find a couple of missing things. So I would like you to put example and take a moment to draw the following triangle. Go ahead, pause the video and draw it now. Alright, let's take a look at using the sine law one more time. So in this example, we need to find two missing angles, x and y, and one missing side, the side labeled as Z. So I'm going to proceed by first finding the missing angle labeled as X. So please put a subtitle, find X. Alright, so again, watch how the sine law can help us find either a missing side or a missing angle for any given triangle. So once again, the sine law states that the ratio of any side versus the sine of its opposing angle. So I'm going to use 9 centimeters, and its opposing angle is the 36 degrees. So I set up my ratio as 9 over sine of 36. That should equal any other side, so I'm going to take the 14 here, versus the sine of its opposing angle, our missing X. So to write that down, 14 versus sine of X. So if we do our cross multiplying, we end up that sine of X should equal to 14 times the sine of 36 divided by 9, thereby giving us sine of X is equal to around 0.9143. And then using the inverse sine button on that result, 0.9143, that will give us an angle of around 66.1 degrees. As you can see, the sine law is very convenient for helping us find a missing angle. Next, let's find the missing angle Y. So subtitle please, find Y. To find Y is going to be very easy. All I'm going to do is use the property of the internal angles of a triangle that all add up to 180. Therefore, Y is equal to 180 minus the 36 degrees minus angle X, which we found a second ago to be 66.1. And therefore, Y equals 77.9 degrees. As usual, when you find a value, don't forget to write it in. So I'm going to erase my X and my Y from the diagram. I'm going to write in what I found so far. Angle X was 66.1 degrees, and angle Y was 77.9 degrees. Alright, one more variable to find, which is our side Z. So subtitle please, find Z. And for Z, I'm going to use the sine law one more time. Except this time, I'm going to involve different sides and different angles. So you can pretty much use any combination of a side versus its opposing angle. That's what's nice about the sine law. So for my work, I'm going to stick to using the 9 centimeter versus its opposing angle, 36 degrees. So let's write that ratio down. 9 versus sine of 36. That should equal our missing side Z versus the sine of its opposing angle. Let's get that written down. Z versus the sine of 77.9. And when you do your cross multiplication, you end up with Z equals to 9 multiplied by sine of 77.9 divided by sine 36, and you end up with Z being equal to around 14.97 centimeters. Using the sine law is not complicated at all, and once you gain more experience with it, it also goes very quickly, as long as you remember which pieces to put where. And that's all there is to the sine law.